Now, after we've done our long division, we're going to want to write out what we found. And we did this a little bit already. I showed you that at the very beginning. What does this mean? After you've done your long division, what do these results mean? And this is what's called our division statement. So our division statement looks like this. And to make it shorter, we're going to say this is our polynomial, p. Your divisor is what you're dividing by. I'm going to put a d there. Your quotient is your answer that you get after dividing, plus your remainder. So I always think about ice cream because I think of DQ here, and I went to Dairy Queen over the break twice. That's the problem when it's just 2 blocks away. You go way too often. But it's wonderful. What's that? Yes, nice and close. So good. Yum. Ice cream is a very good thing. I think it must be very healthy. Anyways, so we're going to write this division statement after we divide. Our polynomial is equal to what we were dividing by times our answer plus whatever our remainder is. And as we saw in that example at the beginning, if your remainder is 0, you have started to factor it. In example 2, we add a new thing that comes important with polynomials that never showed up with numbers. Okay? For example, in numbers, you would say, this is 507. No one ever says, zeros aren't important. We should just write this like that. That would be fine. Don't have to write the 0. Is everybody okay that that's also 507 if we didn't write the 0? No. You just have to write a space. So you just have to know, oh, that is that 50,007 or is that 5 million? How many zeros are there? Well, with numbers, we write zeros in there. But with polynomials, we don't, because they're really not important. What's missing in here? There's no x cubes. Who cares? You don't have to write that. There's also no x to the 1 millions. We didn't write a 0x to the 1 million. Well, when we're dividing, that's going to become important. So let's look at this example. We have to make sure we have them in order. So from last time we said, make sure it's in the right order. So your biggest one is 3x to the 4. And your next biggest one is a minus x cubed. There are no x squareds, but I'm going to add that 0x squared in there just so that my columns are all there when I'm doing my math. And I still have a plus 3x and minus 20. So I want to have all of my columns representing every number. You don't have to put in zeros for ones bigger than x to the 4, because then you could go forever, and that's really not important. Same thing with numbers. No one ever does that, right? It's like, this is 107. No one decides, oh, I like to write 107 like this. Is that okay? Well, it's kind of pointless. But we do need that 0 in between, because without that 0 in between, you can't tell that that's 107. And for long division, using polynomials, we will make sure we put zeros in when there's a column that's missing. So now we're going to divide this by x plus 2. We use the same idea as before. What is our biggest value? Our biggest value is the 3x to the 4. What would you have to multiply x plus 2 to get 3x to the 4? 3x cubed. You write that over your x cubed column. You multiply 3x cubed times x plus 2, which gives us 3x to the 4 plus 6x cubed. Put that in brackets and subtract. Sure enough, we get 0 here, and negative x cubed minus a 6, negative 7x cubed, and all of these other things would still be there. Now negative 7x cubed is our largest value. What would I have to multiply in x plus 2 to get a negative 7x cubed? a negative 7x squared. I multiply negative 7x squared. We get negative 7x cubed, which is what we wanted, and negative 14x squared. And this is why that 0 was important to have there, because now when we subtract, this will be 0. 0 minus a negative 14 is plus 14. If you don't write the 0, sometimes you get tempted to put things that don't match up, columns don't match up, your math goes bad, and we'd still bring down the other values, plus 3x minus 20. Now our largest value is the 14x squared. What would I have to multiply x plus 2 by to get 14x squared? Plus a 14x. And so you start to see that this process is very repetitive. Once you get it once, we do the same thing again over and over again. Now with the plus 14x times by the x plus 2, I'll get 14x squared plus 28x. Put that in brackets and subtract. So I get 0 minus 25x, bring down the 20, minus 20. What would I have to do to get a minus 25x? Multiply by minus 25. I'm running out of colors. We'll go red. And sure enough, we get minus 25x. Minus 25 times 2 is minus 50. Subtract negative 20 minus a negative 50 is plus 30. And so we get a remainder of 30. And now that we've done all this, what does it mean? Well, this is where our division statement comes into play. And this question also asked us at the beginning to write the division statement. So the division statement looks as follows. So label it division statement. You might have the DQ thing there so that you remember the order you need to write it in. So we start with our polynomial. Our polynomial is, in this case, was 3x to the 4 minus x cubed. 3x to the 4 minus x cubed plus 3x minus 20 equals, we divided by x plus 2. That's our divisor. Our quotient was 3, negative 7, 14, negative 25. And a remainder plus 30. So if I label things, this was my polynomial, this is my divisor, this is my quotient, and here's my remainder. Yes? Put this, if you graph this, the left side, and you graph this, the right side, they're equal, they would be the exact same graphs. Sometimes what people like to do in questions like this, when they have to write their division statement, they put a little statement, let p of x for my polynomial equal this. And then when you're writing your division statement, instead of writing all of this, you can say p of x equals, and it's a little bit shorter. But you'd have to define p of x at the beginning to be your polynomial that you started with. So practice writing some of your division statements. Now you can do 3b and 7.